Hello, today we'll be talking about chain rule differentiation. First thing is we first need to recall what is a concept we need to remember regarding chain rule. First, let's try to talk about this concept. If you can remember in your junior year, if you can see this, it's f circle g of x and f of g of x. So this is the fifth operation of functions, which is composition of functions. So again, if ever you will be solving this one, for example, f circle of g of x or f of g of x, this simply means that this g of x will be, or the value of g of x will be substituted to the domain of our main function, which is f of x. So let me provide you an example, at least to remind or to remember you on the concepts of composition of functions. So assuming we have f of x is equal to 2x to the power of 5, and our g of x is equal to x minus 1. So say, for example, you're looking for the value of this. All right. So for example, you want to know what is the value or what is the equation for f circle g of x. So if we solve that one, again, as what I've told you, as what I've mentioned earlier, we have f of x is equal to 2x to the power of 5, and g of x is equal to x minus 1, as mentioned. Since this is the outer function, we will be replacing the domain of this with the g of x function. So basically then, if we have x minus 1 as the value of g of x, we will be replacing, or we will be using this to substitute the x of our f of x. So if ever we will be simplifying that, what will happen to that will be 2, all right? Then our x of our f will be replaced with the g of x. Okay, so that's the concept of composition of functions. So that will be x minus 1 to the power of 5. So if you can remember, that's how you do it if ever you will be doing composition of function f circle g of x. So technically then, sir, what if you will be doing it vice versa? What if we have g circle of f of x? So how do we do that? So technically, if ever we'll be rewriting it, it will be g of f of x. So the same concept as earlier, um, the value of f of x will be used to substitute to the domain, or it will be used to substitute to the x of our g function. So let's go back to the given that g of x is equal to x minus 1, and our f of x is equal to 2x to the power of 5. So if we solve this one, then what will happen is our g of x is x minus 1. All right, so since it's x minus 1, we will be replacing the x minus 1 here with the value of our f of x, and f of x equal to x to the power of 5. We replace our x by 2x to the power of 5. So then g circle of f of x will be equal to 2x to the power of 5, because again, x and x is, or x will be replaced by 2x to the power of 5, then minus 1. So that's how we do it. So that's how we solve composition of functions. So these were the things you learn with your previous year. So, how is it applied in chain rule, or what? How is these, or how are these concepts being used in chain rule? In chain rule, though, if ever we will be solving for or getting the derivative using the chain rule method, what we will be doing is basically the given is already this function, So what we are doing for chain rule is we will break this composed function into its original two functions. All right, um, I just want to emphasize that the given for if ever we'll be using chain rule differentiation is we have this, and what we will be doing is we will go back to the original function. We will break it into two parts, wherein if we simplify it this way, the answer will be that one. So if we have this, we need to go back to these two original functions. The same thing if, for example, you are provided with this, what you will be doing is we will go back to the original function. So here, let me provide you with, let me just show you again first with the theorem for our chain rule differentiation. So assuming for our chain rule differentiation, we have h of x. So our function is just equal as a composed function, f of g of x. So again, I just want to emphasize there are two functions here. The function g of x being put inside the domain of our f of x. So that's the concept of the composition of function. So what we will be doing here is if ever we'll be getting its derivative of the function, so the derivative of this one technically, what we will be doing is this is the formula. So be guided with the formula. So the formula, so the derivative of h of x is h prime of x, if you can remember, and that is equal to, so as what I've told you earlier, what we will be doing is we will break this composed function into two parts, which is we need to know the value of our f of x, or the equation, and the equation of our g of x. So we need to break it, and then afterwards we will be getting its derivative, and these are the procedure in solving using the chain rule function. So it's like f prime, so the derivative of f, making sure that the domain is g of x. So f prime of g of x times the derivative of g of x. So don't worry, I'll provide you examples so that you will be able to understand the concepts clearly. All right, so again, the key here, the difficult part here is actually how we break the composed function back to its original two functions. All right, so let me provide you with some examples here. Let's proceed to the first example. So solve for the derivative of the following functions using chain rule. All right, so we need to make sure that we'll be using chain rule. So in this function then, y is equal to 6 times 5x cubed plus 7x plus 8 to the power of 12. What you'll be doing here is, again, as what I've told you, we need to know our f of x, the outer function, and we need to know our g of x. Because if you can remember, y is just equal to f of g of x. Oh, by the way, let me just write also the let me write the formula. If you can remember, it's h prime of x is equal to f prime of g of x. Again, that's what I've told you. Just be guided with this formula times our g prime of x. So in this thing, then technically, our g of x is the function inside. It's the one being substituted to the domain of our outer function, which is f of x. So that is why then we can conclude that this is our g of x. This is the one being substituted. So we can say that our inner function, 5x cubed plus 7x plus 8, is our g of x. And so our f of x then is 6 x to the power of 12. So why is that so? Because if you substitute this to the domain, to the x of our f, what will happen? We replace that, and I believe it will be like that. All right, so that is why, that's how we break it. That's how we divide it into two, and I mean divide it back into its original two functions. Right, so to continue, because our goal here is to solve for the derivative of y. So what we will be doing here then is, so since we need to solve for the derivative of y, again, we need to focus on this format. So if you notice, we have derivative of f and derivative of g. So what we will be doing is, of course, just solve for the derivative of f. So if you solve for the derivative of f, this will be 6 times 12 x to the power of 11. Right? And if we simplify that further, 6 times 12 is 72x to the power of 11. And for g of x, its derivative, I believe, is g prime of x, and that will be 5 times 3, 15, x squared plus 7, and I believe 8 will be 0, so there is no point of writing that. So if you notice, these are the derivative, or these are the derivatives of our functions f of x and g of x. All right, so to proceed with this derivative, so the derivative of y then, using the chain rule differentiation, it's f prime of g of x times g prime of x. So what is your f prime? Our f prime is 72x to the power of 11. However, if we go back here, our f prime is being substituted with g of x. So that is why 72x to the power of 11, our x here, if you'll agree with me, our x here will be replaced by g of x. And our g of x is this, right? So instead of writing 72x to the power of 11, we replace x, and that will be 72 times the g of x, which is 5x cubed plus 7x plus 8 to the power of 11. So this is our f prime of g of x. So to write that formally, it will be, well, let me just transfer this one first. No, sorry. 1 minute. I'll transfer the. Well, I'll just erase that. All right, so let me just move it closer here. So the derivative of y is just equal to f prime of g of x. So this is it. So that will be 72 times 5x cubed plus 7x plus 8 to the power of 11, then times the derivative of g of x. The derivative of g of x is equal to 15x squared plus 7. So you can put 15x squared plus 7. And so to solve further, I believe we can just combine them. So we can just write that as 72 times 15x squared plus 7 times 5x cubed plus 7x plus 8 to the power of 11. And you multiply, you distribute 72 here. So 1 minute before we substitute, let me just write it clearly. So, sorry, it's 11. And distribute 72 times 15, I believe that will be equal to 1080 x squared. And you multiply 72 times 7, it will be equal to 504. So then the derivative of your y is equal to this, and these are the steps using chain rule differentiation. Okay, so let's proceed to another example. Let me provide you with our next example, which is y is equal to 8x to the power of 4 minus 3x cubed plus 2x squared plus x minus 5. So again, to remind you that our derivative is equal to f prime of g of x times g of prime. All right. So again, our challenge here is we need to know the two original functions before we have this composed function. So we need to know the value of f of x and the value of our g of x. So if you will be doing it through inspection, you'll be able to notice that the inside function is this entire thing. So that is why I think you'll agree with me that our g of x is 8x to the power of 4 minus 3x cubed plus 2x squared plus x minus 5. And if this is the function being put inside the x of our f, then our f of x is x to the power of 3. Because if you substitute this to the x of f, it will be this expression to the power of 3 going back to this given. So that's how we break it into two. That's how we put it back to its two original functions. So as what I've told you, this is the most challenging part. So to continue, we solve for f prime of x. And I'll think you'll agree with me that its derivative is 3x squared. And the derivative of g prime of x is equal to 8 times 4, 32 x cubed minus 9x squared plus 4x plus 1, and it's minus 0, and it is still 0. So these are the information we need in order for us to apply this formula. So again, I just want to emphasize one thing here, that it's f of prime of g of x. So the concept here is the x of f of prime will be replaced with the equation of g of x, or with the function g of x. So that is why if we have this f of prime of g of x, this will just be equal to this x will be replaced by g of x. So this is our g of x. So what will happen, it will be 3 times our g of x is 8x to the power of 4 minus 3x cubed plus 2x squared plus x minus 5 to the power of 2, because it's x squared. Then times, you multiply it, because this is f prime of g of x, times the derivative of g, and the derivative of g is equal to this. So you multiply it with 32x cubed minus 9x squared plus 4x plus 1. And if you rewrite this, what will happen will be, so technically you write the expression having the highest exponent. So that is why I write this one first. That's how you arrange normally. So squared times, what you'll be doing is you distribute 3 to everything inside this parenthesis. So what will happen will be 3 times 32 is 96x cubed minus 3 times 9 is 27x squared plus 3 times 4x is 12x plus 3. Well, in this example, I will accept this answer. However, I just want to emphasize that there might be some books that you'll be asked to simplify this, all right? Which is, it is just to the power of 2, so you multiply them, and then you multiply it with this. However, this answer will do, and this is the final answer for this. Well, actually, if you want to review, if your answers, on chain rule is correct, you can apply the 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 process when you will be doing it using the general power rule or the extended power rule. You can verify the answers for that. But again, this process we're doing is for the chain rule differentiation. All right, so let's proceed to the last example. And the last example is this. So we solve for the derivative of y is equal to cube root of x plus 2 all over 2x minus 3. So this is quite challenging. All right, so let me write first the formula, okay, just for you to be guided, all right? Just for you to be guided with the formula of our chain rule differentiation. Again, it's if we have h of x, h prime of x, the derivative the derivative is f prime of g of x times g prime of x. All right, so going back again, the challenge is to know the original functions, f of x and g of x. All right, well, I think you'll agree with me. If you wish to rewrite this, this will be x plus 2 over 2x minus 3 to the power of 1/3. If you can remember, radicals can be expressed as exponential having a fractional exponent. Okay, so that's why instead of writing the cube root thing, we can just write it as 1/3. So I think you'll agree with me that our g of x, which was being substituted to the value, to the x of our function f, is x plus 2 over 2x minus 3. So technically then, the function inside the function, or the function inside the parenthesis, is usually our g of x. That's the function being put inside or being substituted to the x of the outer function, because our outer function here um, our outer function here is f. If you notice, for example, if you write that, this is the outer function and that is the inner function. The same thing as here. This is the outer function and this is the inner one. All right, so then if this is being substituted to f with its x, so x then, f of x then is just equal to x to the power of 1/3, because if you substitute that, x will be replaced by this thing and it will be less like this. So that's how we broke the composed function back into its original composition of functions, the original two functions we had. So if we solve for its derivative, this will be f prime of x, and this will be 1/3 x to the power of 1/3 minus 1. And so to solve further, this will be 1/3 x to the power of negative 2/3. And if you can remember, if we have negative exponent, what you will be doing is you put it down to make it positive. So this is the derivative of f of x, which is f prime of x is equal to 1 all over 3x to the power of 2/3. All right, so let's proceed to g of x. So to solve for the derivative g of x, so seems like the operation involved between the two of them is division. So it's right then to use the quotient rule. If you can remember, the syntax for quotient rule is vu prime minus uv prime all over v squared, making sure that our u is our numerator and our v is our denominator. So if we solve, this is u prime, so derivative of x plus 2 is 1. And let's go to v prime, the derivative of 2x minus 3 is 2. So we use these four values to solve for its derivative. So using this format, so v is 2x minus 3 times u prime, which is 1, minus u, which is x plus 2, times v prime, which is 2, all over v squared. And our v is equal to 2x minus 3 squared. All right, so we can simplify this by merely distribution. So if you multiply 1, I believe it's just equal to 2x minus 3. And if we distribute this, it will be 2x plus 4. So as mentioned, if you notice, it is enclosed with parentheses. Yes, because there is a negative symbol here. Yeah, the negative operation, because we need to distribute first the negative one. So be very careful, as mentioned. If you have a minus operation here, you need to make sure if the expression after that is binomial and beyond, meaning binomial, trinomial, and any other, you need to put it inside a parenthesis because we need to distribute the negative operation. So negative times 2x, that will be minus 2x, minus times positive 4, that will be minus 4. And so to simplify further, 2x minus 2x is 0. So again, 2x minus 2x is 0. So this one and minus 2x will be 0. And what's left is negative 3 minus 4. That is negative 7 all over 2x minus 3 squared. All right, so what we will be doing next is, since we have the derivative of f, we also have the derivative of g of x, which is this. We go back to our chain rule differentiation, which is this one. Okay, this is the syntax. So the derivative of y is just equal to, again, our f of x is this. We replace the x value of this to the original one. So what will happen will be 1 over 3 times our x will be replaced by x plus 2 over 2x minus 3, because this is our g of x to the power of 2/3 times. All right, so that will be times times the derivative of g. The derivative of g is negative 7 all over 2x minus 3 squared. All right, so the challenging part here is how we simplify. All right, so how we simplify this specific expression. So if you simplify this, be careful because we have a complex fraction here. It's like a vinculum over another vinculum. So just be very careful. So this will be simplified as, because this is in the denominator, I think you'll agree with me that we can just reciprocate it, right? Because if, for example, we have, 1 minute, for example, we have this. Please eyes on this part. So if we have 1 all over x over y, technically that will be y over x, right? We can reciprocate it. So the same thing here. The same thing here. If we have this will just be 1/3 times, it will be 2x minus 3 over x plus 2 to the power of 2/3. Then times -7 all over 2x minus 3 squared. All right, so afterwards, we combine. So we can put -7 over 3 here, -7, 3. And I think you'll agree with me that we can distribute our exponent. So that will be 2x minus 3 to the power of 2/3. And this will be x plus 2 to the power of 2/3 times, this will just be 1 because -7 is being placed here. So 1 all over 2x minus 3 squared. So I break, or I distribute 2/3 here, because if you notice the 2x minus 3 here, this expression and this expression are having the same basis. So we can combine them. So how do we combine them? So we can have y prime is equal to -7 over 3 and 1 times. So we can put it down. Why is it so? Because 2/3 is the exponent here and 2 is the exponent of our denominator. The denominator has greater exponent. So that is why we will be placing the lesser exponent that back down to the denominator. So this will be x plus 2 2/3. And let's just put it here. So that will be 2x minus 3 to the power of 2 minus 2/3. All right. So then our final answer will be y prime is equal to -7. I can just -7 times 1 times 1 all over, all right, all over 3 times x plus 2 to the power of 2/3, and then 2x minus 3 to the power of 2 minus 2/3. I believe it is equal to 4 over 3. All right, so then this is our final answer. Y prime is equal to -7 all over 3 times x plus 2 to the power of 2/3 times 2x minus 3 to the power of 4/3, because 2 minus 2/3 is equal to 4/3. All right, so basically that's it for the day. I hope you learned a lot from our discussion, and that is all about the chain rule differentiation. All right, thank you so much, and goodbye for now.